So today we're going to be going over calculus, that's the inverse trig functions, and then to be specific we're going to be going over differentiation. So if you're not a subscriber, subscribe right now. Also share with other students who take calculus so they can benefit from this. This is an easy step on how to derive the derivatives of inverse trig functions. So we can start with the derivatives, right? We're looking at the derivatives. So now inverse trig functions are things like let's say y is equal to sine inverse of x. So now if you're being told to find dy by dx, what are you going to put? Things like y is equal to cosine inverse of x. So it's just a trig function, except it's to the power -1. Others are tan inverse of x. Y is equal to maybe cosec inverse of x. As long as there's an inverse, it's an inverse trig function. So now how we derive this is, we know dy by dx is the same as 1 over dx by dy. So now this is the main idea of deriving this, because we know that we can easily derive dx by dy and not dy by dx. So we first derive dx by dy and then now come to this one. Now how are we going to achieve this? We're going to achieve this by using a simple rule. So you can start with this one. We'll start with sine inverse of x. So we are being told y is equal to sine inverse of x, and then these are arbitrary. They can be t, they can be anything. So now when we have something like that, we can take the sine of both sides. Thus we are going to have sine y equal to x, or in other words, you can just take the sine the other side, and then when it goes the other side, it will now become sine and will not have an inverse. So then this one we can easily differentiate dx, because we know now dx is like a function of y. So dx over dy is then equal to, we know the sine inverse, we know the sine of the derivative of sine y rather is equal to cosine y. So then we know what dx by dy is, but then we let our x equal to sine y, and thus we must make this cos y look like this one, so that we can replace where there's x. We're going to put whatever we're going to find there. So now we know cosine squared y plus sine squared y is equal to 1. So for us to have the cos y as subject of the formula, we know this equation. We know that when we make cos y subject of the formula, we're going to have sine y, although it's squared, but then the sine y, we know what it is with respect to x, and so we're going to have something like cosine squared y is equal to 1 minus sine squared y. When we take the square root of both sides, we're going to have cosine y being equal to the square root of 1 minus sine squared y. So then this is equal to that. So now we can conclude that dx over dy is equal to the square root of 1 minus sine squared y. Now sine y, we know it's x, so you can replace wherever there's sine y and put x. So to make this more clear, I will say dy by dx 1 minus sine y, this one is squared, so dx by dy is equal to 1 minus, where there's sine y, we're going to put x, so we're going to have 1 minus sine x squared. Then remember, this is dx over dy, but then we want dy by dx. So then we're going to change this one by saying dy by dx is equal to 1 over dx over dy, which is 1 minus x squared, and thus we found our answer. So now this x can be anything. It can be t, perhaps it can be 2t. If it's 2t, we're going to put our 2t there, then we square it to be 4t squared. So then we go to y is equal to cosine inverse of x. Then now we go to this other one. y is equal to cosine inverse of x. So as usual, we let x be the subject of the formula, or let x be a function of y. So I'm going to say x is equal to cosine y. When we take the cosine of both sides, or when we take the cosine inverse to the other side, so then we're going to say dx over dy is equal to sine, negative sine y. Then we try to make sine y in such a way. We're going to use the trig substitution and the trig identities in such a way that we're going to have a cosine y so that we can replace with the x. So now we are being told that sine squared y plus cosine squared y is equal to 1. So then we can take the cosine the other side. So sine squared y is equal to 1 minus cosine squared y. When we take the square root, we're going to have sine y being equal to 1 minus cosine squared y. So now where there is sine y, we can put whatever we found there. So then we're going to have dx by dy being equal to negative the square root of 1 minus cosine squared y. Then we are going to get now dy by dx by taking 1 over dx by dy, which is negative the square root of 1 minus cosine squared y. But then this is dy by dx, so the variables in here should be x. So we're going to replace wherever there is cosine, we're going to put x wherever there is cosine y. So dy by dx is equal to 1 over the negative of the square root of 1 minus x squared, and thus we found the derivative of y is equal to cosine inverse of x. So in the next part of the video, I'm going to go to y is equal to tan inverse of x.